Hi everyone, in today's lesson we're going to talk about how we can solve first degree trig equations. So let's just take a look at an example. So here it says, solve for all values of theta that satisfy the equation below. So this is called a trig equation. Why? Because there's an equal sign and we're trying to solve for theta that satisfies the left side and the right side. And we want to find that theta over the interval from 0 to 360. And we want to round all of our answers to the nearest tenth if necessary. So you want to treat trig equations honestly like regular equations. So actually what I would do first is change this to the trig value. So you see I have cosine and cosine. I would let x equal cosine of theta, and I would solve the equations with x's first and then put cosine of theta back in. So this would be 5x plus 2 equals x plus 2. And what I would do is solve the equation for x. So we would minus x on both sides, and then we would subtract 2. So you would get 4x equals 0 and divide by 4, and you would simply get x equals 0. So since we solved the equation now in x's, we're going to put what we let x equal, and we're going to put it back in. So since x was equal to cosine of theta, we're just going to say cosine of theta equals 0. So we're trying to find at what angle is cosine equal to 0. So since we have 0 degrees, we should be thinking about the unit circle. So we're looking for an x value to be 0. Why? Because x is equal to cosine of theta and y is equal to sine of theta. So this problem here is asking us cosine of what angle theta gives me 0. So we're looking for an x value to be 0. So I see that here and here. So this is 90 degrees and 270 degrees. So my final answer here for theta, there are two values. Theta is either equal to 90 or theta is either equal to 270. That's it. All right, I'm actually going to skip this next one, and we're going to actually do this one in class tomorrow. Let's jump to the next page now. All right, so I still have the exact value chart and the unit circle, which we might use. Let's solve these problems now. They say solve for all values of theta that satisfy the equation below over the interval from 0 to 2 pi. This means we want our answer in radians. If it was in degrees, we would say from 0 to 360. So we're going to do the same thing that we did before on the first page, and we're going to let x equal the trig function that we see. So we're going to let x equal secant of theta, and we're going to isolate it. So rad 3 times x equals negative 2. And to get x by itself, we're going to divide by rad 3. So x is equal to negative 2 over rad 3. So now we're going to do exactly like we did before. We let x equal secant of theta. So we're going to put it now as x is secant of theta is negative 2 over rad 3. Now, anytime we have what's called a reciprocal function, right, this secant or cotangent, we must write it in terms of sine or cosine or tangent. So we have to bring this back to cos. And we know the relationship between secant and cos is that they're reciprocals. So simply switch the fraction and flip it. So now that we are dealing with cosine, we want to know cosine of what angle is negative rad 3 over 2. Well, rad 3 over 2 is very familiar to me. I think it's somewhere up here on this exact value chart. So cosine of what angle is rad 3 over 2? Well, 30 degrees. So what this tells me is that cosine of 30 equals rad 3 over 2. I know there's a negative, but I want you to just disregard the negative for now. And we're just going to say that theta is 30 degrees. And now let's talk about that negative. So this value right here says cosine of theta is a negative rad 3 over 2. So what this negative tells us, placement, it tells us where we are. So all students take calc. Since cosine is positive here and here, it implies that cosine is negative there and there, quadrant 2 and 3. So these are the two quadrants in which angle of theta will give me a negative rad 3 over 2. So what you found here, this 30 degrees, this is your reference angle. And this reference angle will help you find the whole angle in quadrants 2 and 3. So it's helpful if we draw a picture. So if I have a reference angle in quadrant 3, or 2, let's start with 2 rather. Here is the angle, the whole angle where I start with. My reference angle we know is this small piece here. If I know this is 30, how could I find this whole angle? Well, I can take 180 and subtract 30, and that will give me theta. So in quadrant 2, we will do 180 minus the reference angle, and that will give me 150 degrees. That gives me this whole angle. Okay, let's do the same thing, but now the angle is in quadrant 3. And let's figure out how we do that. I'm going to draw the picture for quadrant 3 over here. So the angle is here, whole angle. And my reference angle, remember, is the small piece between the terminal side of the angle and the x-axis. So if I want this piece, all I would need to do is take this 180 degrees and then add 30 more. So my angle in quadrant 3 is 180 plus 30, which is 210 degrees. So these two are my answers, not the 30. The 30 helped us get the answers, right? We're in quadrant 2 and quadrant 3. Now, technically, the directions state that we need to have all values of theta between 0 and 2 pi. So we need to change our degrees into radians. So if you remember, the way that we convert them is by taking the degree and multiplying it by pi over 180. And remember, multiplying fractions tops with tops, 150 pi over 180. And you can just simplify the 150 and 180 and tack on the pi. So they're both divisible by 3 or 30. So 5 pi over 6 would be the simplified version. Now we're going to do the same thing for the 210. So we've got 210 times pi over 180. Again, put this over 1. 210 pi over 180, tops with tops, bottoms with bottoms. And they're both divisible by 3. So 7 or 30, 7 pi over 6 would be that final answer. All right, I think that's enough for today. We can do this second example in class tomorrow, and that's it. So if you have any questions, now's a good time to jot them down. Otherwise, we'll see you guys tomorrow. Have a good night.